seen that marginally is present, right? Whatever section we have provided. Then we use to see how to pass the bit. Right? Then only option is that how to reduce the load. So that is the option. There are so many options by which you can reduce the load. Right? That is the option. So in some working that some opening should be there. So due to the opening, some percentage should reduce. Right? So once that has proved that the opening it varies from 10 to 15%. So whatever side you can consider this. Right? That is the logic. Is it visible clearly? এটা কার মডেল তোমার? ও আমি আনিছি। ওকে। এই সব কি দেখাচ্ছে সরাও কি? ওকে। What is this? I don't this one. How to remove this one? Oh. এটা থাকবে? না সাইডে সরিয়ে দাও। Okay. So recording is going on. Okay, no problem. So I believe that all of you have completed up to this, right? So your next part is that you will have to assign at the node. So before that you must have to finish modeling property, section property means size of that section, and also the material property. Material property means if your structure is made by RCC or steel, right? So now to assign that the load, you will have to okay, ready all of you? So to assign the load, there is a load page. Click on loading. Right side. Don't do this right now. If you want, you can write down the steps. Right. So click on load page. Right. So there is an option which is called new. Click on new. Right. Then there are so many options: definition, load case, load item, like that. So click on load case. By default, your loading number will be 1, and this will be the dead load. And load case 1, you put your title, suitable title, say dead load. Right? And add it. Then close. So whatever dead load title we have given, it will show you. That part you know it, na? Then click on the dead load and click on add. And there is an option which load to be added. Right? Here self weight y direction -1, add it. Right? If you recall, in your design of steel structures, similar thing we have done. So using that the self weight y -1 command, it is showing that a red question mark. Red question mark means where that command to be assigned. Right? So now by dragging, you select all those members and click this command and assign to selected beams. Change that option and click on assign. Yes, you see whatever red question mark was there earlier, so that has been converted into green box. It means that using that command, self weight will be calculated automatically by the Staad. Here you have already prepared that the modeling yes or no. It means you have drawn center line distance, right? Accordingly, each member you have assigned the section property. Am I right? Right? And also you said that which will be that the material property, either steel or concrete. So accordingly, Staad is capable to calculate that the volume of that concrete and from that the volume of the concrete total weight, right? So using that the command self weight minus 1, whatever modeling you have done or whatever element you have modeled in that package, so Staad will calculate everything related load. Fine. You need not to calculate separately self weight of all beams and column. Again, I am repeating. You have modeled beams, all beams. Hey, hello. Isan Bhatia. What is it? Why you are talking? After this, then you will ask. Right? So self weight means Staad will be calculated whatever elements you have modeled. Simple. Right? We have modeled only the skeletal board. All beams, all columns. That's all. So that's why fine. So under dead load, you know, all self weight of all beams and all columns will be there. And also under dead load, self weight of force will be there. But those we have not modeled. We have not modeled any plate element, right? So, and also we have calculated that the dead weight of slab, right? Or we have designed the dead weight. We have designed the slab and we got it. So approximate depth is 130. And for 130 depth of slab, what is the raw weight of concrete that we have calculated? And using the load finish, yes, that we have considered 1. Total is 4.25 kN per meter. So if you put that the loading intensity in that frame, then Staad is then capable to calculate it. Right? Let's see how to provide that one. Again, click on dead load, click on add, and that the slab load, it will be placed in the form of floor loads. Click on floor loads, right? And it will ask you in which direction that the load will be provided. Definitely at the y directions. So click y range, and here the pressure intensity, whatever loading intensity you have calculated, that you put it with that negative sign. 4 point minus 4.25. You know the reason why it is negative. By default, y axis positive upwards, our load is acting downwards. And also there are some ranges, x axis, y axis, z axis. Each axis has some minimum range and maximum range. It means that whatever loading intensity you have provided, where this load will be applicable. Because you have several panels, na? Here, where, right? Where it is provided. And also you know, along the direction x, you are having longer length, along z, shorter length, right? It means that your building plan is xz plan. Xz plan, am I right? Why is that? Right? So if you keep x-axis and z-axis 0, 0, Staad will understand that whatever loading intensity provided along shorter direction and along longer direction, it will put the same value. Fine. Regarding vertical directions, starting from first floor to whatever the height, if you provide that the range, right? So Staad will understand that between that height, that height, whatever floors are there, right? So entire floor, this value will be applicable, right? So what is the top height? Someone please note it. Minimum range 4 meter, minimum 4 meter, y top range 37.9, 37.9, fine. Now again I am repeating that command. Dead load, add, floor load, change the directions, in which direction you want to provide that the load, say this is y directions, put that the pressure intensity which you have calculated manually after design minus 4.25, global y directions, keep x and z directions, x range minimum maximum, y z range minimum maximum 0 0, so that entire floor will be applicable same loading intensity, but you will have to change that the in y ranges, right? Tell me the minimum 4, maximum 7.37.9. So add it. You see, whatever load you have provided, automatically it has distributed, right? And you have seen, if you remember, if it is two-way, hello, your distribution will be like this. Capital part will go to the longer side, right? Triangular part will go to the shorter side, right? If you cut any one of floor, you see the isometric view, you see the graphics, how they have distributed all the panels, right? Hmm? Just we put the loading intensity accordingly. Staad has distributed load. Longer side capital portion, shorter side. If you want to see that the load value, that is also possible. If you press Shift V, hmm? Shift V. So Staad will also show you that the loading conditions, right? How it has distributed in shorter span and longer span, right? Shorter span and longer span. Basically, this part, similar thing you have done it in your field semester sessional, I think. Yes or no? Loading panel, how you have distributed? Manually you have done, na? So that part, SCAD is taking care of. Hmm? Your just task is that you will have to put that the loading intensity. That's all. Right? And here important thing, you see that left side, this panel load is not showing. Do you know why? Hmm? Because of the staircase, right? But how the stair will understand that there is staircase? Yes. Interesting part is that this command will help if if the pressure intensity will get that closed loop, right? Closed loop. If it gets the closed loop, then only that command will fall, right? So if you see this side, one side will be this, closed loop is not, right? That is the open loop, right? That's why. So though I have provided the command for all panels, but if if there is no closed loop, that command will not work. Fine. Because the everything has set it. Another part, we did the mistake. Which one? Yes. Deep panel, we have transferred the load at the whole level. Right? You have seen that in the deep block, starting from ground floor to the top, right? That is totally vacant. Deep from there, right? Otherwise, how the car will move, right? So that's why, though it is easy with the single command, all cases will fulfill, but here you did the mistake. You have taken the additional load, right? Yes or no? Yes. And to avoid that part, what should I do? Hmm? Hmm? You are an engineer. You have to think about it. Hmm? You have considered the additional load. So here there is no closed loop, that's why the command is not working. But here closed loop is there, that's why the command is working. Huh? How we put it here? One possibility is there if you provide that the upward direction unload for particular that region. But that is not scientifically true. Unnecessary, you are confusing the package. Sometimes you are telling that basically it is obeying your command. Na? Sometimes you are telling that you work that side. Immediately you are telling that now you work that side. Unnecessary, your calculation will be complicated. What to do? What to do? Cancel the beam. But it is not possible because both sides leap drop beam should be there. Combine কাজ করার জন্য beam হাওয়া করবে অসম্ভব যেটা তোমাকে কোম্পানিতে হাওয়া করবে now what to do होगा जरूर होगा बताओ लगाओ दिमाग हाँ हाँ कैसे बनाओगे ग्रुप कैसे बताओ that is one option but there is another shortage option anyone can you guess it कैसे करोगे कैसे होगा वो नहीं होगा ना क्योंकि वो same command is working entirely if you see I have put one command na simply I have put this command and it is working entirely proving one that will take time you have to do all those things yes that is the option yes so if you see this is your x directions z directions right so first if this is a 0 0 right so say this is your void right and this is your again another void right so but this is the solid part so definitely this direction x will have some minimum value x min x max similarly this will be the z max z min like that huh? In that way you can control that one right so again please prepare with that coordinate so whatever loading I have taken I have removed fine again self weight someone please help me write down x is equal to 0 Z is equal to 5.8, the coordinate of this point, right? Write down x is equal to 26.6, sorry 27.6, Z is equal to 0. But here Z should have some values, no? Yes. So Z is equal to 0, x is equal to 27.6. Okay. Another point. Write down x is equal to 6.9, Z is equal to 5.8. X is equal to 27.6, Z is equal to 9.5. Fine? X is equal to 0, Z is equal to 9.5. X is equal to 27.6, Z is equal to 16.3. Fine? So I will have to put three comments. Add floor load minus 4.25, right? Y range starting from port to, what was the range? 37.9. X range, you please tell me the first set. What is the minimum value? 0. Maximum? No, no. 27.6. Similarly, Z minimum 0, I think. No, Z minimum 0, maximum 16.3. If you add it and you check, what happened? No. First set. Consider the first set. Whatever first set, three set will be there. I told you the three set. X Z range 5 point. Yeah, only that the first set. First set loading is there, right? Now tell me the second set. Another command you will have to take. Full load minus 4.25, and that is the same value 437.9. Now you tell me the X range, second set. Minimum is 6.9. Maximum is 27.6. Z range? Minimum 5.8. Maximum 9.5. You add it and check. Yes, no. Again you made the mistake. Z is equal to 9.5. Oh, X you made the mistake. X will be 20.7. No. So your X is up to here, na? 20.7. So this value you 20.7. Fine. Hey, beam half of the follow. Third set. You take another command. Full load minus 4.25, 437.9. X range tell me 0, maximum 27.6. Z range 9.5. 16.3. Can you add it? You check. Yes. Now you check the entire floor. If you want single floor to view, yes, you see only your desired portion load has been assigned or you want it, right? So likewise, you can control your loading for a particular height, for a particular floor using X-ray, Y-ray, Z-ray. Here, suppose if anybody wants, just for a particular floor, I am having something more load for library course. Rest of the part, it is similar, right? For a particular portion, now we should provide the additional load. That's fine. So this is all about your mom room and lip room. Mhm. So you have not put that the range, that's why it is not coming. You see what's the coordinate? 39.9. Till it is not showing. Why? 37.9. 37.9 showing. Make it 40. Yes, separately we have to put because that is out of range. Whatever comments we have given in the middle one, X range is something, X range is not there up to that limit. Right? So that's why separately, okay, no problem. That is out of range. Whatever three comments we have used, again, please tell me. Write down. X is equal to 20.7, Z is equal to 5.8, Y is equal to 35.4, X is equal to 27.6, Z is equal to 9.5, Y is equal to 37.9. Fine? Load, add, same method. Load 20, minus 4.25 and Y range, tell me the minimum value. No, 35.4, maximum 37.9 and X range minimum 20.7, maximum 27.6, Z range minimum 5.8, this one 9.5. Add it, close, fine. Now you see the all view, all the floor have been loaded. Live load also. same method, right? Sometimes for a particular tool, you will be using for toilet, you will be using for kitchen, you will be using for stove, for each cases your light load is different, right? So if the light load is different, so that is the way by which you can provide the zonal loads. And now tell me if you have got any questions. Yeah, no, staircase load you will have to calculate mountain room also. Same method mountain room also you will have to first pick up the node coordinate. You put it accordingly. I am not repeating. Right? Next is that how to assign that the cell point of your wall. Right? To assign the cell point of the wall, again you will have to take that the loading intensity under dead load. Select the dead load first, click add, and that will be under yes member load. And you select the loading intensity, what? 13.5 minus 13.5, add it, and also some interior beams or interior columns minus 6.75, add it. Again you see whatever loading intensity you have taken, it is showing with the red question mark, right? Again the package is asking you in which directions or in which member the load has to assign. So this is the roof, parapet wall will be there only. So you cut, select, right? So here if you see, except roof and ground floor tie beam, we have taken the intermediate members. You go to the plan view, there you will see beams, but perpendicular directions you are having that a column also, right? So your load will assign only on beams, not column, mind it. So that's why you will have to select only the beams. The method is that go to the select menu, beams parallel to X, beams parallel to Z, and you will have to confirm that if all the beams have been selected or not. I click on isometric view. Yes, if you see all the beams have been selected except column vertical beams, right? Yes. Partition wall. Partition wall is different. Why? Interior. Partition wall thickness go to the calculated now. 6.5. But we have to assign different. As you are saying that, definitely we will do. Let's see. Let me complete. Right? Selected object. What we need? We have selected all the beams in different group except roof and frame. Fine. So now each question is that partition wall loading intensity is different something compared to the external. Right? So we select the external wall first. But question is that how to select? This is the isometric view, na? So here one thing confirm, there is no column. Yes or no? Only we have selected beams, including exterior beams, including partition beams, right? Whatever, secondary beams. Your skeleton body is like this. Simply you go to that plan view, top view. So you will be seeing only beams, right? So now you select that the loading intensity for exterior wall. Select this one by dragging. You select only that the exterior beams. Fine. Assign to selected beam. Assign. Assign. And if you see, you will be seeing only the external walls are loaded. right? There is no load in the intermediate beams, right? So float load is creating some problem. Yeah. If you see, only the external wall load is showing. Hmm? Right? Only external wall load is showing. But similarly, we can provide the inter partition wall also. You take another command, add member load. What is the loading? Minus 6.75. Add it. Now you select all the intermediate beams. I am considering that these are all intermediate beams. Am I right? Where the partition wall will be there. Check if columns selected or not. No. This, and you select this one, assign to selected beam. Yes. And if you check any one beam, now tell me what is your question, right? At the same time you have assigned the external load, same time you have assigned the internal beam load, partition wall, right? So that is the load level which we have assigned. Clear? That's the method. So today you complete up prayer. Hmm? Next step. হ্যাঁ সেকেন্ডারি ইমেজ ওয়াল ডায়াগ্রাম করবেন মনে করো আপনি পাঠিয়েছেন ছিল না বুঝতে পারবেন ঠিক আছে তোমার প্ল্যান যদি না থাকে দেবেন ধরিলাম সেকেন্ডারি ইমেজ আছে সেটা দিলাম okay so one point is asking that if the loading is necessary on the secondary beam or not but as per your plan if it is required you put the load otherwise forget about it. Right? While your wall is there you put them. That's all. Now tell me if you have any confusion. Okay. So if you see, intentionally I left roof because parapet height is something different, right? If the parapet height is 1 meter, generally by practice parapet height is 0.75 meter or zero point 0.7. So I am considering the height of the parapet is 1 meter. 1 meter. So for 1 meter, 0.1 wall thickness, 0.25, 0.25 into 20, 5 kilonewton per meter. So again you take one loading intensity 5 kilonewton per meter under dead load. Go to the add, click on member load minus 5, add. So again go to the elevation, you cut only the top floor, right? And parapet wall, you know, only the exterior wall will be there, right? So you first select that the load and select that the beam where that these two beam, this load will not be there because staircase height is something different, right? Accordingly, whatever load will come, you will have to put it on these two beams, right? But here, this 5 kilonewton per meter load will be there. Fine. You see, you got it, na? I am not calculating that one. You see this one, fine. So, starting from here to here, and also at the top of that mounting room, at the top of that the machine room, this parapet wall load will be there. Clear? I am not showing it. Means roof of the mounting room. That is that for the maintenance purpose, you can use to provide the parapet. Huh? Scientifically it is wrong. For maintenance purpose, carpet should be there everywhere, right? So people will go there, na? Somebody will go there, na? So he or she is having some life, you know. Yes, everybody have other processes. So that is scientifically wrong. And simply I am telling you, if it come to me for betting, simply I will cut it. Yes. So I left the typing, right? I am assuming that entire portion will be used for car parking, right? But lift and stair will start from ground, right? So that portion some load will be there. Fine. Again go to that elevation. You cut this tie-beam part, cut it. So this is my lift portions. This is my whatever stair portions. Fine. Fine. Yes or no? Floor height is 4 meter. Again you calculate that the load. Someone please help me. 0.25 into 20 into 4 minus 0.6. Tell me what's the value? 1.7. So that is the loading intensity around that the stair block. Clear? Similarly, that side your lift block is there. I told you that thickness of the lift, I mean CR wall, RCC wall, you should provide 150 to 200. How much you are comfortable? So 200. Right? For 200 mm, RCC wall. So that load has to put, because we are not modeling that the CRO wall. So 0.2 into 25 into what's the depth? 4 minus 0.6. Someone can help me. It will be same, I think. So, 17, no? Because here thickness was 20, 250, unit weight was 20, but here it is reverse. Thickness 200, unit weight is 25. That's why 70. But instead of 200, let's consider 175 to make 35 value. 175. 175 is the thickness of CR wall or RCC wall, right? Consider 175 is the thickness of RCC wall if nothing is mentioned. Now please help me. What is the value? 14.875. So these are the two data. Again, you will have to pick up under dead load. Member load. First one is how much? 17 minus 17. Add. Another one is minus 14.875. 875. Add it. So which portion is stair block? Left side or right side? Left side stair block. So this 17 load has to select this, this, this. Am I right? This side, this side, this side. Now it is okay. So assigns. Fine. Similarly, this load will be assigned right side. Fine. And if you see the isometric view, it looks like this. কি হয়? This side of that stair. Sorry. Okay, so now if you see the whole body, so your loading diagram looks like this, right? Looks like this. It means that whatever possible dead loads are there, all you have considered, right? All you have considered. Three side leaf block we have assigned the load. Reason is that three sides will be solid, one side will be free to enter the person. Right? Similarly, same case. Your stair also. One side will be open, na? Otherwise, how the member will right? Clear? Everybody? Now tell me.
स्टार्ट हो गया